Have you ever wondered what it would take to build the perfect flying machine? Well, that's what we're going to do today. We're going to reverse engineer one of nature's greatest marvels. We're going to break it down piece by piece, from the frame to the engine, to really understand how to build a bird. Okay, so let's just start with a kind of wild thought. What if the dinosaurs never really went extinct? What if they're actually still all around us, just, a lot smaller and covered in feathers? The evidence for this is absolutely incredible when you see it laid out like this. So on the left, you've got a classic theropod dinosaur, and on the far right, a modern pigeon. But look at that guy in the middle, Archaeopteryx, from about 150 million years ago. You can see it's still got reptilian jaws with sharp teeth, and its bones aren't fused together. Now compare that to the pigeon. It's evolved a modern toothless bill and a skeleton where tons of bones have fused, all to make it lighter and stronger for flight. And that brings us to our first section, the flying dinosaur. You see, Archaeopteryx was that perfect missing link that blew scientists' minds right when Darwin was publishing his theory of evolution. It just perfectly sets up our big question. How in the world did we get from a reptile that walked on the ground to an absolute master of the skies?
Yeah, this transformation wasn't a single giant leap. It was this slow, gradual process playing out over millions and millions of years. You can almost watch it happen here. So 200 million years ago, a dinosaur's arm couldn't move all that much. But by 175 million years ago, the shoulder evolved rotary motion, which is a huge deal if you want to flap. Fast forward to Archaeopteryx, and you see those arm bones getting longer, getting reinforced. And all of that leads us to the modern bird, with its super mobile shoulder and fused hand bones creating a powerful, lightweight, and just perfectly aerodynamic wing. Okay, so we've seen the evolutionary journey from reptile to bird. Now let's get into the nitty-gritty. Let's look at the actual blueprint for flight, the incredible hardware that makes up this aerial machine. The first component is just an engineering masterpiece, pneumatic bones. So unlike our bones, which are solid and filled with marrow, a bird's bones are hollow and filled with air. Now, to keep them from being super fragile, they're reinforced with this internal network of crisscrossing struts, kind of like the trusses you'd see holding up a big steel bridge. The result? A skeleton that is unbelievably strong, yet almost impossibly light. And get this, the total weight of a bird's entire skeleton is often less than the weight of all of its feathers combined. Just let that sink in for a second. We're talking about an airframe that is designed purely and perfectly for the sky. Of course, that airframe needs an aerodynamic surface, and feathers are totally unique. No other living animal has them, but they wear out. And that's why birds molt. It's a process that's just as vital to their survival as finding food. A new feather just grows from a follicle in the skin, it hardens up and then unfurls, pushing the old tattered one right out. It's a constant, life-saving renewal system. So we've got a super light frame and a high-tech covering. Next up, we need a high-performance engine to get this thing off the ground. Section 3 is all about the incredible internal systems that power this machine. The demands of flight are just extreme. It requires a massive amount of energy. To put that into perspective, just look at this number, 700. That's how many times a rufous hummingbird's heart beats per minute. Now for comparison, a healthy human heart is somewhere between 60 and 100. This tiny little bird's heart is a biological jackhammer, working at 10 times the human rate just to power its flight. And to fuel that incredible metabolism, birds evolved the most efficient respiratory system of any vertebrate on the planet. See, our lungs are a two-way system. Stale air mixes with fresh air, which is not very efficient. Birds, on the other hand, developed a one-way system. Air flows constantly through their lungs into these air sacs, giving them a pure, undiluted supply of fresh oxygen. It's basically a built-in supercharger, letting them perform even at super high altitudes where the air is thin. Okay, so we've assembled our basic model. We've got the lightweight frame, the feathers, and a supercharged engine. But one size doesn't fit all, right? Section 4 is all about the specialized toolkit, the bills and feet that customize this machine for every possible environment out there. And this is where things get really cool. The bill isn't just one tool, it's an entire toolbox. You have the greenfinch's strong conical bill for cracking seeds. It's a perfect little nutcracker. Then there's the falcon's sharp hooked bill for tearing flesh. The hummingbird has that long, thin probe for sipping nectar. And the flamingo's bill is this crazy complex filtration system. Each one is a totally specialized tool for a very specific job. This specialization starts right from birth, too. There are basically two main strategies. On one side, you've got nidicolous chicks, like sparrows. They're born naked, blind, totally helpless.
They need constant care, but the upside is a shorter incubation time. On the other side, you have nidifugous chicks, like ducks, who hatch with fuzzy down feathers and their eyes open, ready to leave the nest almost immediately. The trade-off for them, a much longer time developing inside the egg.
All right, our machine is fully assembled. We've built it piece by piece. So for our final section, let's see what this thing can actually do. Let's look at the incredible feats this machine is capable of when we put it all together. The result of all this fine-tuning is just breathtaking performance. Think about this number, 25,000 miles. That's pretty much the same as flying around the entire circumference of the Earth. It's also the round-trip distance the Arctic tern flies every single year, migrating from the North Pole to the South Pole and back again, all to chase an endless summer. It is the longest migration in the entire animal kingdom. And if that marathon endurance isn't enough for you, how about just raw speed? When a peregrine falcon dives to hunt, it can hit speeds over 200 miles per hour. It literally folds its wings and becomes a living missile. I mean, these are performance stats that human engineers can only dream of building. Now, you would think that these perfectly engineered survivors would be invincible, but even they are facing some serious modern challenges. Right now, more than 1,200 species are classified as either vulnerable, endangered, or critically endangered. And the biggest threats are things like habitat loss and other human activities. The truth is, these magnificent machines are far more fragile than we might think. And that really brings us to our final thought. For 150 million years, evolution has been at work perfecting this unbelievable flying machine. We've just spent this whole time seeing exactly how perfectly they're built. So the question that's left for us is, can we be perfect caretakers?